Hi, it's Mike Klempa from Alphawave Semi. I'm the OIF's Interoperability Working Group PLL Chair, and we're here at OFC 2025, just demonstrating interoperability at 112 gig and 224 gig. And then we're also taking a look at all the challenges, having discussions on what it's going to take to get to the next rate and what 448 gig is going to look like. We have a workshop in a couple weeks that we're really building up some great momentum for. And so we're just having some great discussions here at OFC, talking about what are the possibilities, what are the challenges, what are the opportunities, and really digging in, having some great conversations on how to enable an ecosystem at 448 gig. Let me show you around our massive demo booth. Lots of interoperability at 224 gig and 112 gig. So this CEI 224 gig linear and 224 gig RTLR demonstration shows multi-vendor, multi-technology interoperability at 224 gig, representing a potential deployment use case for LPO with half-retimed modules in the front panel of a high-radix switch and an LPO in a network interface card to access a scale-out network. A pattern generator sending PRBS 13Q is going through a 1.6T half-retimed optical module through the M module compliance board, including an ISI channel in between to represent that host loss. The optical connection over single-mode fiber is then split for a scope clock recovery and analysis before going to a link partner in a 1.6T OSFP LPO. The oscilloscope is displaying the resulting far-end eye diagram, representing the termination and equalization of a far-end receiver capability as a TP4 electrical output measurement. So what we're showing here is a 224 gig SerDes driving a completely passive interconnect. So it's a MCB plus a passive DAC, a 1 meter DAC. And we're showing an open eye at the far end using this Keysight scope and reference receiver software. We're also showing the trade-offs or to extend the reach of these copper interconnects if you're not looking to go too far and you don't need optics, by putting a CTLE, so a linear boost on the far end. So we call these ACCs. They are still adhering to the CEI IA spec for LR, but you're getting a little bit more reach without a big hit to the power profile. And again, it's all multi-vendor interoperability from the connectors, from the SerDes, and also to the samples of DACs and ACCs. What we're showing here is a time domain network analyzer demonstrating channel characteristics of a cabled near chip and cabled host connectivity plus OFC breakout to test fixturing, totaling over about 20 dB of channel loss, which is referencing that chip to module type of reach with a cabled host. It's getting us more reach than the PCB traces, but also provides the flexibility to get to that front port. We're also showing a cable backplane system, a very high dense connector that can increase your reach over very manageable thin twin-X. This CEI 224 gig linear demonstration leverages test equipment to generate a PRBS 13Q PAM4 212 gig signal, which is then sent over an ISI trace loss board to reflect the current IA's die-to-die loss target from a host ASIC to the chip, used to perform the linear compensation and the conversion to an optical signal, which is then terminated and displayed with a TDEC-Q measurement on the scope. So what we have here is a technology demonstration for 448 gig. We have a Sienna DAC ADC generating PAM4, PAM6, and PAM8 signals, showing the analysis and trade-offs between cardinality, required SNR, FET coding gain, power consumption, latency, connectorizations, and channel loss. And this is actually the channel that these signals are going over to get a reference for how short these reaches are. And so we're doing a lot of work to figure out how to enable an ecosystem at 448 gig. This VSR interoperability demonstration includes test tip silicon from 2 SerDes vendors, leveraging a VSR channel operating at 212 gigabits per second. Using a ISI board to achieve the target loss, it represents a switch ASIC to front panel pluggables, enabling 1.6T optical connectivity. This demonstration encompasses the entire ecosystem, enabling multi-vendor CEI linear interoperability, and is complemented with the new half-retimed RTLR energy-efficient interfaces architecture efforts, noted with the fiber drops between tabletops in the OIF's OFC 2025 booth. A 51T switch on one table is interoperating with multi-vendor SerDes and test platforms emulating Ethernet devices, driving both single and multi-mode, multi-vendor linear pluggable optics, and half-retimed RTLRs while demonstrating quality BER with FEC tail margin at minimal power consumption.